Hello guys, today we're going to talk about sex-linked traits, and those are the traits that are passed to the offspring from the parents, and we will discuss the recessive type and the dominant type on the X chromosome. We will also discuss the role of Y chromosome in males, and let's look into the X-linked recessive. So let's see, this A that I designed is a recessive gene for some kind of disease, and let's see, female right here is affected, and male here X chromosome not affected. So when you get this offspring, uh, none of these two guys are affected with these traits, but this one is, because there's no comparison, no competition coming from the Y chromosome for this A trait. And this is the only one on this particular uh, gene level, because Y chromosome is very very short, and it does not have all the genes and all the alleles. So the phenotype or does not appear for this particular gene on Y. So this A become dominant here. So this is the only guy is going to be affected. So 25% of the offspring is going to be affected with that particular disease or trait. Now, to have it appear on this particular example, where on the male side, on the female side, sorry, this is female side, and this is one more time. So this is the female side, and this is our male side, and both chromosomes are affected here. Both parents are affected, and this become dominant at that point. So that's why you said you need two copies of that trait from both chromosomes to be present for that particular offspring to be having that trait. Now this is not going to be affected because A is recessive, so it's not going to be appearing in this offspring, and this is going to be affected because this is the only one um, uh, present on the X chromosome, and there's no competition on the Y. And this person is pretty much clear, doesn't have, it's not carrying that trait um, further on its offspring when it creates its own gametes. So this is the example for recessive one. Let's talk about dominant. Dominant always gonna be appearing no matter what. So on the female side, and this is male side because this is Y chromosome here. A is present right here in this offspring, so it's a dominant. So this guy is going to be affected, and this guy is also going to be affected because A is dominant plus Y chromosome doesn't have competition coming for this particular trait. So 50% of the population are going to be affected. Now let's talk about a little bit of mitochondrial situation when you have a disease in mitochondria. So let's see, this is a mitochondria, here's the mitochondria right here, and it has a mutation in here. And this mutation is going to be passed to the offsprings because this is in the cytoplasm of the egg of the mother. So when sperm comes in and make a fusion with the egg, sperm doesn't have any cytoplasm organelles in it. So any problem in the mitochondria from the mother side is going to be passed to the offspring. So this is just something you have to keep in mind, that any mitochondrial diseases will inherit by all the children of that particular um, disease. So that's it. I briefly talked to you about X-linked recessive, X-linked dominant, and a little bit about mitochondria. So if you have any questions, go ahead, put it in a comment, or like the channel, leave a comment, thumbs up. I'll see you in the next video with more information. Till then, you have a good